Exercise 11b. I included this, y equals a times sine b outside of x plus c, bracket, bracket, plus d. So the amplitude is a, the period is 2 pi on b, or for our case 360 degrees on b. The phase shift is c, that's the movement in left or right, and here it's got plus c here, so positive is to the left, okay? And d is the vertical shift. And here is how it looks on a graph, so that's a great, so refer back to this during this video. Note that we are using radians here, not degrees, and there are 2 pi radians in full rotation. Okay, great, so that would be basically 360 on B there. Okay, and I think I got this from math, oh there we are, mathsisfun.com. Thank you. Question 1, for each function, predict the amplitude, the period, the equation, the principal axis, and the range. So I've listed them out here, A, B, C, and D. Amplitude, that's the amplitude from the middle, up and below. So the first one, that's A, is 3. A is 0.5, A is 7.1, and absolute A here is 5. 5 up and 5 down from the center line. The period is 360 divided by 4 because it's 360 divided by B, and B here is 4. It's 360 divided by B, which is 0.5 on the bottom there. It's 360 divided by 3, right, that's B, and 360 divided by, in this case it's a half, so 0.5. The equation of the principal axis, that's the center line of this function here, okay, and this is this number here. So it's our D, that number there, and it's the vertical shift. So this is plus 1, it's normally y equals 0, so it's got plus 1, so y equals 1. This is y equals minus 3, shifted down by 3. This is shifted up by 1, so y equals 1. This is shifted up by 8.1. Now the range is the distance between the center line above, so it's go all the way from the top point down to the bottom point. Well, if the center point is 1 and the amplitude is 3, then the highest point it can go to is 4, and the lowest point it can go to is 1 minus 3, which is minus 2. Similarly for this one here, if the center point is minus 3 and it has an amplitude of 0.5, then the highest point it can go is minus 2.5 and the lowest is minus 3.5. Here, if the center line is 1, it's got an amplitude of 7.1. The highest it can go is 7.1 above 1, which is 8.1, and the lowest it can go is 7.1 below 1, which is minus 6.1. Here, center line is 8.1. If the amplitude is 5, the highest it can go is 13.1, and the lowest it can go is 3.1. 2, for the following graphs, determine the numerical values of the unspecified constants. So we have to find A here. Remember, A is the amplitude. We have to find the center line. The center line looks like it's that line there, y equals 1. Well, we know it is because that's plus 1, and that's the vertical shift. And the distance between the center line and the highest point is 2. And just to double check, the center line to the lowest point is 2, so A is 2. Here, we have to find A and B. Okay, the way we find A is similarly. We know that the center line is now minus 2 here. Okay, minus 2, that 30 refers to the x-axis, so that's minus 1, minus 2. Well, it looks like the amplitude is 1, doesn't it? Because it goes up by 1 and it goes down by 1, so A is 1. Okay, let's look at B. Now B, okay, I've used a capital B here, but that's the B. So the period is 360 divided by B, or therefore B is 360 divided by the period. Now, we can see one complete period here is 180. It's halfway between 0 and 360. So the period's 180. 360 divided by 1 equals 2. So B is 2. And we would expect that from the graph because you can see that it's being compressed. Okay, because that's a 2, the period has been changed to a half of the original period. And C, A is 3. Okay, the midpoint there looks like it's around here. Now that would be minus 1, so we've got D is minus 1. Now if D is minus 1, the high point is 2, so that means A, the amplitude must be 3 up above minus 1, so that would make it 2, and 3 below, that's minus 4. Now if you have a look at this one here, between 0 and 360, that's half of a period there, so the full period would be 760. this would go down here and it would come at 760. So the period is 760. Okay, so if we use this one, B would be equal to 360 divided by 760. So B is equal to 360 on 760 is a half. 3. For the following graphs, determine the numerical values of the unspecified constants. So I've got y equals 2 cosine bx minus 2. We need to find b. Well, b equals 360 over the period. Sorry, I've used a lowercase here, but that reflects directly with that one there. So that's good. So I've got the small b is 360 over the period. So that's 360 divided by 180. Now the period is from here to there, the peak's here. So that's 180. So 360 on 180, b must equal 2. This one here, b, we've got y equals a cosine x plus d. We have to find a and d. Well, d is an easy one to find because it's the midpoint between here and here. So that's 1. D equals 1. That's the vertical shift there is d. Normally here, but it's shifted up 1, that line. And now a, well, if 1 to 4 from the middle point, the center line up to the peak is 3. So that's the amplitude. Okay, now we've got to find a, this a here. Now look over back, let's go back to this one. This was cosine, and that is the cosine curve. So if you shifted that up, it should be peaking at x equal 0, and it does. Now it's a little bit different here. We're using cosine, not sine, so we're using cosine. So if you were to look at this against a regular cosine curve, this has been reflected in the x-axis. Because this peak is normally on the other side. It normally goes up like that and down like that. So that's why there's a negative sign. And it's negative 3 because the difference between the center line and the top peak is 3 and there to there. But that's why it's negative. Now have a look at C. We have to find A, B, and D. Okay, D's an easy one to find. D's the midpoint between the peaks. So it looks like it's 0. So D is 0. Now, that is 2.5 above 0 and 2.5 below 0. So A is easy, that's 2.5. Now it's cosine, so we don't have plus or minus. We don't have to worry about plus or minus, I should say. It's plus because that's our regular cosine function. And then we've got to look at B. Now if we count the period is going to be from peak to the peak here. So that's going to be 720 again. So the period, as we can see from here, is 360 divided by 720, so that's a half.